Good morning, sir, and good morning, everyone. This morning, we will report and discuss the topic all about Formworks. So today's presentation, these are the outline of topics. Introduction, Formworks key elements, Formworks typical, basic Formworks, shoring and scaffolding, and last is the computation. So before we proceed, I will introduce to you my group mates, the group 3. Yours truly, Dave Rovel Villesa, Alisa Joy Divila, Maria Mirasol Jane Migano, and John Steven Fuscablo. The first reporter for Formworks key element is Maria Mirasol Jane Migano.
Good day everyone. So I am Maria Mirasol Jane Migano and our report is all about Formworks. So what is Formworks? Formwork is the term used for the process of creating a temporary mold into which concrete is poured and formed. Traditional formwork is fabricated using timber, but it can also be constructed from steel, glass, fiber, reinforced plastics, and other materials. So, ang formwork is a temporary support structure which is ginagamit as mold o bilang amag para ibuhos ang konkreto o semento. So, ang formwork is very important in producing good concrete. Shuttering is perhaps the most popular type of formwork and is normally constructed on-site using timber and plywood. A special grade of plywood is necessary for shuttering, and it must be water resistant. It is easy to produce, although it can be time-consuming for larger structures. It is used when the labor costs are lower than the cost of producing reusable formwork from materials such as steel or plastic. It also has the advantage of being at a significant amount of concrete can be poured at once. So shuttering, it is a part of formwork, which is a vertical temporary support structure na ginagamit to bring concrete in the desired shape. So ang shuttering is most popular type of formwork. So ginagamit sa pag-construct sa site is timber and plywood. Next is Formworks key elements. So formwork used to shape and support fresh concrete until cured and able to support itself. So muna sa ang formwork, it is a type of framework. So do framework siya, di ba? Kaya niya supportaran iya nga kalingon. So next is shoring. Shoring is temporary support is designed to carry forms for beams and slabs. So, shoring is a temporary structure ginagamit to prevent the collapse of the main under construction structure. So, for example, to relieve the load on a masonry wall while it is repaired on reinforced. So, we have forms for concrete construction. So, these construction materials used for form construction. First, we have the lumber forms, a collective term for harvested wood, whether cut into logs, heavy timbers, or members used in light frame construction. So, ang lumber forms, also known as timber. It is a timber formworks. Most common type of formwork among all others. So, it is used for bracing, and it is called as traditional formwork, which is the oldest type of form used in construction. So, ini isang type of forms is most flexible type. So, its advantage compared to other formworks is easy to produce and remove, lightweight compared with metallic formwork. So, ang metallic formwork muna sila ang steel and aluminum forms. Plywood forms used where a smooth surface is required. Should be waterproof, grade A and at least 1/2 thick. So, ang inisa nga forms, it is used along with timber. It is a manufactured wooden materials which is available in different sizes and thickness. So, ang plywood and timber formwork ay may similar ila nga properties, which is same ila nga strength, durability, and being lightweight. Parehas ila nga kamag-anon kag katibayon. So, it easy to handle and its life is too short compared to the other materials. So, mostly ang plywood is very useful gid sa construction. Steel forms may be in the form of pans for concrete joist construction or steel decking or corrugated steel for concrete slabs and slab and joist construction. So, ang steel forms is one of become more popular due to its strength, durability, and it is reused for a long period. So, ang steel is costly for small work but can be used for a large number of projects. Fiberboards. Low-density fiberboard is also known as particle board, and it is mostly used as underlay in various rooms of a house, such as the kitchen or bathroom, and for furniture manufacturing. So, fiberboards as a kind of natural fiber composite made from wood or non-wood fiber materials. So it is also used as a building material in residential and commercial building. So usually this is a heavier than plywood or dimension lumber. Phenolic boards. A thermosetting, waterproof, low-cost, mold-resistant, high-strength synthetic resin made from phenol and formaldehyde. Has good resistance to aging, used extensively in the manufacture of adhesives, exterior and marine plywood, laminated products, and molded articles. So, ang phenolic boards is widely used in construction industry, which is to create the wooden molds that are used for casting concrete, such as making concrete slabs and pillars of buildings. So these boards are completely waterproof grade plywood.
So, good morning everyone. My name is Dave Ruvel Villesa. Formworks typical. Ang traditional formworks is fabricated using timbers kag pwede man kagamit sa mga metal or steels, glass fiber, reinforced plastic, and other material. So, sa formworks typical, dira nyo makita ang actual formworks na ginagamit. Just like sa picture nga inyo makita sa presentation. Dira nyo makita ang mga joists, pwede man siya metal or wood, mga sheeting nga or pwede man siya gamiton sa plywood or metal, kag mga formworks nga ga-support sa beam, columns, kag madamo pa nga other things. Next slide. So the next topic is all about the basic formworks. Next slide. So first is the beam forms. Formworks for beams takes the form of three-sided box which is supported and propped in the correct position and to desired level. The removal time for formwork will vary with air temperature, humidity, and consequent curing rate. Typical striking time are as follows using air temperature of 7 to 16 degrees Celsius. So the beam side must contain 9 to 12 hours. The beam soffit is 8 to 14 days. And the beam props is to 15 to 21 days. So some beams can be formed independently to span walls, columns, or part of the floor slab system. So, kung tawagan natin ang propping is a system of structural members used to temporarily to support loads during construction. And ang soft fits naman is generally horizontal and underside of any construction element. Picture show that dapat ang imo props is tadlong kag hindi sa tiko. Kay kung tiko inay, base bala hindi na sa kadalas ang load niya ginadala or nga ara sa beam. Next slide. Next is the column forms. This consists of a vertical mold of the desired shape and size of the column to be poured as a means of keeping the formwork's material thickness to a minimum. Horizontal steel or timber clamps or yokes are used at equal center for batch filling and at varying centers for filling that is completed in one pour. The head of the column formworks can be used to provide support for the beam formworks, but while this gives good lateral strain, it can make the formworks complex. Alternatively, the column can be cast to the other side of the beams. Later on, a collar of formworks can be clamped around the cast column to complete the casting and support the incoming beam formworks. Column forms column forms is type of a concrete formworks. It is a mold made of steel, aluminum, timber, plastic, or other materials in which wet concrete is poured to achieve a desired shape and size. The clamp used to serve temporary hold work securely in place, and the whale is used to maintain alignment. Next slide. Next is the plastic forms. Reusable plastic formworks is generally used for quick pour of concrete. The formwork is assembled either from interlocking panels or from modular system, and it is used for a relatively simple concrete structure. It is not as versatile as timber formworks due to prefabrication requirements and is best suited for low cost repetitive structures such as mass housing scheme. Stay in place structural formworks is generally assembled on site using prefabricated fiber reinforced plastic. It is used for concrete columns and piers and stay in place, acting as permanent axial and shear reinforce for the structural member. It is also provide resistance to environmental damage for both concrete and reinforced bar. These are the advantage of using plastic forms: waterproof, lightweight, high working ability, cost, saving, and high temperature resistance. And also, pwede pa siya magamit sa next construction kung hindi naman ito sunod niya i-construct ang plastic forms. Next slide. Wall forms. Wall formworks was originally comprises of squared timbers and boards. This has resulted in modular systems that are characterized by a wide range of application and long service life. Based on the respective construction, a distinction is made between girder wall formwork and panel formworks. In the presentation, may mga pangalan dira nga ara sa wall form. So, dari ang 5 kabilog na dapat ara sa imo wall forms. First is ang sheeting, shape and retain the concrete. So, makita niyo sa picture, amo na siya ang ara sa daang, amo na ang plywood, amo na sa para tadlong. Ang studs, formworks, and supports the sheeting. Wales to keep aligned. Ang braces hold the forms, and ties hold the side of forms in correct spacing. Next slide. And last is form ties. A form tie is an accessory used in formworks used to hold the concrete wall forms firmly against the lateral pressure of freshly placed plastic concrete. They maintain equal space between the forms, which result in uniform thickness of wall. A form tie contains two parts, namely internal tension member and external holding device. Removal of ties are completely hardening of concrete depends on type of tie used. Some tie can be removable and some are not. So this end of my report of the basic formworks.
We have here the shoring and scaffolding. So scaffolds are temporary platforms designed to support workers and materials on the face of structure and to provide access to work areas above the ground. Okay, above the ground itself. So any elevated platform is called a scaffold. So ginagamit ini sang mga workers para tungtungan nila kung gaobra sila sa mga high-rise building, sa mid-rise building, ginagamit man ini. Kag this is very important also in formworks. Itakol naton ini subong. Okay. So the major components of a metal shore are A, the ledger or the horizontal brace, the brace or the diagonal. This component may be of the adjustable and fixed type. C, the standard or the vertical component. D, accessories, the heads, jacks, and bases. So let's tackle these things, the major components of metal shoring. So first there is the ledger. Ledgers are 48 millimeter diameter tubes with a cast wedge fixing device at each end. They are positioned horizontally between the two vertical scaffold standards to give the length of the scaffold bay at a platform level. They may be also be fit as a handrail. Okay, so nakikita natin sa aton nga picture ang kundi nakalocate ang ledger. Okay. Next here is the diagonal braces. Diagonal braces is a scaffold tube placed diagonally with respect to the vertical and horizontal members of a scaffold and fixed to them to give the scaffold stability, longitudinal, facade or sway. So next here is the bracing. Diagonal braces is installed in a plane of the longer dimension length of the scaffold. Okay, so amo na siya. Diri na siya nakalocate ang diagonally nga position amo na siya ang diagonal brace as you can see to the in the picture. Okay. Okay, next here is the standards. Standards is an uprights or vertical tubes. Okay, vertically naman siya guys. So nakikita natin sa picture. Used to support, okay, to support the load to the ground. Scaffold tower can be erect in all shapes and size. The standard dimensions are 5 foot and 7 foot long. Okay, nasa siya ang iyang dimension and reaching 5 foot high all the way up to the 30 feet tall. Amo na siya. So located there sa picture ang standard. Amo na siya ang iyang itsura. Okay. Next here is the U-jack or U-heads. Okay. So the last thing nga very important and the major part sang scaffolds. So U-jack or U-heads are designed to be used in conjunction with the adjustable system scaffolding. Okay, kita nyo na sa ang picture. The main function of a U-head is to hold timber beams and securely in place. The huge heads jacks offered by us are of the superior quality standards, and these have a pure zinc planted finish, thus adding shine to it. Okay, amo na siya ang U-jack or what we call U-heads. Okay, so next here is the base jacks. Base jacks are insert into the bottom end of the standards to the provide the required and vertical height adjustments. Base jacks are also considered the feet of the scaffold structure. So amo na siya ang base jacks amo gina sa ang pinaka ah, ang kumbaga ang amo ginang pinaka bottom end nga naga-support sa scaffold. Okay. So let's watch the short video clip nga ipakita naman guys.
Oh no, 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 no. Isa to sa mga worst nightmare ko whenever nagbubuhos kami ng slab is magigiba dahil at this point of construction kung saan binubuhusan nyo pa lang yung slab. Yan yung weakest and most vulnerable point niyan. Dahil habang bagong buhos ang semento at basa pa lang ito, hindi niya pa kaya suportahan yung sarili niya. So magre-rely ka dun sa mga forms, dun sa ilalim ng slab natin. So titignan natin dito. Meron silang mga forms. Kung saan meron ako nakikita kulang dito sa Formworks, dun sa ilalim ng slab or dun sa mga humahawak sa slab natin. So kailangan pati Formworks kino-compute din ng civil engineer or ng structural engineer yung spacing and yung taba ng pipes na gagamitin nyo dahil ang weight ng concrete ay 2.5 tons per cubic meter. So ano ba itong sinasabi mong random numbers and cubic ka pang nalalaman? Parang bastos yun. Pero hindi bastos ang cubic, aray. Ang isang cubic, ang ibig sabihin nun ay isang cube na 1 meter by 1 meter by 1 meter. 2.5 tons yun or kasing bigat siya ng isang malaking kotse. So, ganun kabigat yung concrete na kailangan hawakan ng Formworks. So, yun yung rason bakit di nyo pwedeng inventohin na lang yung hawak sa concrete. Kailangan talaga merong structural design din yung Formworks. Also, kung titignan natin ng malapitan, makikita natin dito sa gilid ay medyo nagfe-flex na yung kanilang Formworks. So, pag sinabi kong nagfe-flex ay parang nagbe-bend ng ganon. Kita niya muscle na yan? Nag-work. Walang connection. So, halimbawa ito yung Formworks natin. Medyo nagbe-bend na siyang pag ganon. So, nagfe-flex na siya dun sa gilid na to. So, dapat first sign of flexing ng mga forms, ititigil na yung construction. So, dapat yung supervisor or kung sino man in charge, tinitignan niya rin yung nasa ilalim. Also, isa sa mga rason bakit kadalasan mag-fail yung ganto dahil hindi isang buong bakal yung ginamit sa Formworks. So, feeling ko itong Formworks nila ay dalawang pipe na pinagdugtong na ganon and then may maliit lang na pipe sa gitna. So, isa yun sa mga sinasabi ko sa mga trabahador namin na wag nilang gagawin pag Formworks na ng slab. Wag silang magdudungtong, dapat isang buong pipe na yung gagamitin nila or kadalasan ang gamit namin sa site ay H-frames. So, isa pang nakikita ko dito is kulang sila ng diagonal support. So, ito yung isa sa mga in-emphasize sa akin ng engineer namin sa site na dapat ilalagay ko. So, ang diagonal supports ay halimbawa, ito yung ating forms. So, dyan nakakabit yung mga forms natin. Hindi enough yung ganyan. Dahil, pag tinulak mo to dito, may chance na tutumba siya dahil wala kang support pa ganon. So, dapat lalagyan mo siya ng diagonal support na ganyan. And pa ganon, para yung forces na magpupush dito, hindi siya agad-agad matutumba. Kung titignan natin yung pagkatumba nitong Formworks nila ay pahiga siya. So, most likely, kulang ito dun sa diagonal supports. So, yun lang yung architect's point of view ko sa mga rason kung bakit nangyari to. So, keep in mind, madudes, opinion ko lang ito and hindi ito yung definitive na rason bakit nagiba to. Pero, yun yung mga tinitignan ko pag nagpapagawa ako ng Formworks para sa slab para maiwasan na mangyari.
Thank you, Architect Lian. So, these are the scaffolding tips ang discuss naman sa inyo subong. Okay. First, here is the tip number 1. Ensure the ground and sleepers are adequately prepared and the base jacks and standards are in correct positions. So guys, based on sa aton nga nabasa, dapat nga aton nga i-ensure gid ang aton nga base gid pinaka-base para hindi matumba ang aton nga scaffold. Okay. Dapat ara gid sa correct position. So tip number 2 is assemble tower of standards and ledgers. Fix braces to stabilize. So we need to fix the braces para mangin stable ang aton nga scaffold. Next tip number 3 is loose fit the remaining components until the majority of the first level complete. Check the standards for vertical and tighten ledgers. So, dapat naton nga i-check ang aton nga mga vertical and tighten ledgers para hindi mabuwag ang mga parts sini. Next tip is tip number 4, position scaffold boards and ladders. Okay, so we need to position the scaffold boards and ladders. Guys, tip number 5, additional ledgers and braces can now be added with additional braces. So, naka-build na kita sa aton nga base, we can add the additional braces para mapataas pa ang aton nga scaffold. Next is the tip number 6. Once all levels are complete, jacks and heads can now be positioned. Okay. So, ara nang aton nga jacks kag heads sa babaw. Pwede na naton mabutang. Okay. So, let's watch this short video clip before turning to the next reporter. Thank you guys. Enjoy.
Oh, andyan pala kayo my dudes. Ang technical term na ginagamit para sa mga supports or para dito sa formworks ng slab ay staging. Pero kadalasan ang term na narinig natin na tawag nila dito ay scaffolding. Pero medyo hindi tama yun. Ang scaffolding is tungtungan lang siya ng tao pag meron silang gagawin. So hindi siya technically supports. Although yung mga pipes na ginagamit sa staging ay kadalasan ginagamit na rin sa scaffoldings para multi-purpose na siya at hindi masayang sa pera. So isang halimbawa ng scaffolding na pwede rin gamitin for staging ay itong H-frame kung saan dinesign siya na kaya niyang i-carry yung weight ng slab. And dahil nga kaya niya buhatin ng slab, syempre pwede na rin siyang pang scaffolds na ang bubuhatin niya lang is yung weight ng workers niyo. Halimbawa ginamit niyo itong pang scaffold pag may magpipintura sa labas. H-frame ang tawag dito dahil mukha siyang H. Ayan, madude. So, ganito yung ginagamit namin kadalasan sa site. So, kung titingnan natin yung unang part ng kanilang slab staging ay itong tinatawag nating cement spacer kung saan dito nakapatong ang ating shoring or itong main natin na vertical support. So, yung purpose niyan ay para hindi nakakoncentrate lahat ng force dun sa maliit na part nitong pinapatungan niya. Which brings us to the second part ng ating formworks, which is itong tinatawag nating scaff jack or scaffolding jack. Okay, madun sa hawak ko dito ay isang sample ng scaff jack na hindi nakakabit. So, ganito yung itsura niya pag walang tubo. So, ang purpose niya ay papatungan niyo siya ng pipe sa tuktok kung saan ma-adjust niyo yung height ng pipe by rotating this part. So, meron siyang screw. Pag pinatong niyo yung pipe at medyo hindi siya umabot sa ceiling, pwede nyo pang itaas ng onte. So, yun yung purpose ng scaff jack. Dahil kadalasan, ang nakikita kong ginagawa nila ay sinisingitan lang nila ng maraming plywood or mga bato para lang umabot ng saktong-sakto dun sa taas. Yun yung magpapa-unstable dun sa formworks natin. So, next part ng ating slab staging ay itong ating vertical support, which in this case, ang ginamit nila, tulad ng sabi ko, ay H-frame. Pero kung ayaw nyo naman gumamit na H-frame, pwede kayo gumamit itong mga galvanized iron pipes. So, ayan, galvanized iron pipes. And then, sa tuktok niya, kung makikita nyo and kung kaya nating abutin. So, ayan, kita nyo ba, madudes? Okay, so kung titignan nyo sa taas na yun, meron tayo yung tinatawag nating scaffolding cap. Ano yung narinig ko na yun? May construction worker ba? Okay, wala. Baka may pusa lang. Okay, yan yung tinatawag nating scaffolding cap or in layman's term yung tawag namin dyan ay sombrero. Dito meron tayong sample ng sombrero. So yung purpose nitong scaffolding cap ay pinapatong siya dun sa ating main vertical na support. So ganyan. And dyan yun na ipapatong yung ating main beam supporter para dun sa slab. Halimbawa, ito yung ating main beam supporter. Ganyan, dyan yun siya itapatong. So yun yung purpose niya is para hindi siya gagalaw-galaw at hindi dudulas basta-basta itong main beam na support. So kung aakyatin natin to, so ayan, itong ating scaffolding cap, and kadalasan inaalambre yan para talagang siguradong nakasecure itong ating main beam na support para dito sa slab. So ito yung tinatawag natin na main beam member, kung saan directly nakapatong siya dito sa ating scaff cap, and sa kanya pinapatong itong ating mga sub-members na magsusuporta dun sa ating kadalasang ginagamit dito ay phenolic board, or in this case, yero siya or sheet metal. So yung spacing nito ay 30 centimeters on center. So pag sinabi kong on center, pag sinukat yung gitna ng member na to at gitna nito, dapat 30 centimeters. And yung spacing naman ng ating main slab supports ay 1 meter on center din yan. So yun, madudes, ang kadalasang ginagawa nila. Alright, and I guess tapos na tayo, madudes. But wait, there's more. Meron yung kadalasang nakakalimutan ng mga taong gumagawa ng staging para sa slab ay itong ating diagonal members. So, supposedly, dalawa ito, pero dahil nga partially na baklas na, inalis na nila yung isa, kadalasan, dalawa yan. So, makikita nyo dito. And yung purpose niyan ay para pag meron siyang sidewards movement na pag ganun, hindi siya basta-basta mabubuwag. So, and madudes, ganyan yung staging for slabs, or minsan ang tawag nila para sa slabs ay centering. Pag pader naman or mga column ang inyong pinopormahan, shuttering. So, yun yung kadalasang ginagawa ng mga workers kahit pagbawalan mo sila sa gabi. Mahilig sila mag-shuttering. Anyway, punta tayo dito sa lupa kung saan minsan hindi natin maiiwasan na yung support ng slab natin or yung staging ay nakapatong sa lupa. So isa to sa mga pinaka-importanting bagay ay itong tinatawag nating soil seal or yung papatungan ng ating scaffolding jack. So ang ginagamit ng ibang mga tao ay ganito, kung saan meron lang silang slab ng semento nakapatong directly sa lupa, and then doon na ipapatong yung scaffolding jack. Pero Lian, bakit kailangan pa niyan? Di ba dagdag gastos lang yan? No. Ang purpose nito, again, is para ma-distribute yung weight dun sa mas malaking area. Dahil pag yung scaffolding jack lang yung directly pinatong nyo sa lupa, makikita nyo, napakaliit lang ng area na kanyang nakakover. And pag nadagdagan na ng weight is pwedeng lumubog yung lupa sa ilalim nito dahil napakaliit nga nung inaapak niya. Parang ganito yan, my dudes. Anong mas madaling tumusok sa lupa? Itong pipe or itong scaffolding jack? Siyempre yung pipe. So mas maliit yung surface area na tumutusok sa lupa, mas mabilis siyang papasok. And ang mangyayari, pag pumasok na yung scaffolding jack natin sa lupa or lumubog siya, is magiging uneven na yung support ng ating slab. And minsan yun na yung magkakos ng pag-collapse, is lumubog-lubog yung mga scaffolding jack. So ito yung isa sa mga pinaka-importanteng bagay pag nagpapatong kayo ng staging ng slab sa lupa, which is ang ating soil seal, or yung tawag ko dito is malaking piraso ng flat ng bato. So ayun, madudes, recap lang natin. Soil seal, scaffolding jack, main vertical support, minsan pipes ang gamit or H-frames, and then scaffolding cap or sombrero. And then, papatungan nyo siya ng main beam support, and then mga sub-members na magsusuporta dun sa ating flat sheet ng metal or phenolic board. Tapos, buhusan na yun pagkatapos malagyan ng mga tamang reinforcements.
Good morning, everyone. I'm going to report about the formwork computations. So formwork calculation example. So this example is a one-story residential house. Step 1 is to calculate the concrete perimeter. Calculate the perimeter by adding the lengths of the four sides, A, B, C, and D, and adding an extra 0.2 meters for overlapping of joints. So in this example, the calculation is perimeter is equals to A plus B plus C plus D plus 0.2, and perimeter is equals to 0.2 plus 0.2 plus 0.2 plus 0.2 plus 0.2. So the perimeter is 1 meter. For step 2, calculate the concrete surface area. Multiply the perimeter by the height of the column to get the surface area of the plywood shuttering. So area is equals to perimeter times height. Ang area nga ginkuha ta kagina is 1 meter times 3, which is the height of the column. So area is equals to 3 meters squared. For step 3, multiply by the number of columns. Let's say you're building 8 columns. The total area of the concrete columns will be, so total area is equals to area times number of columns. So ang area, total area na ginkuha ta kagina is 3 meters times 8, which is the number of columns. So the total area is equals to 24 square meters. For step 4, calculate the plywood surface area. To calculate the surface area of the size of plywood you're using, this example uses 1.2 meters times 2.4 meters plywood. So the plywood area is equals to length times width, which is 1.2 meters times 2.4 meters, and the plywood area is 2.88 square meters. Last step is to calculate how much plywood is needed. Divide the total concrete surface area by the surface area of the one piece of plywood. This tells you how much plywood you need to buy. So plywood needed is equals to total area divide the plywood area. So the plywood needed is equals to 24, which is the total area, and divided by 2.88 is the plywood area. So the plywood needed is equals to 8.3. So this means you will need to buy 9 pieces of 1.2 by 2.4 meters plywood along with suitable falsework for support. So here is another former calculation example of 3-story commercial residential. For layout for footings and scaffoldings, we have 1,190 pieces of 2 inches by 2 inches times 10 feet lumber, which is 3,927 board feet that costs 15 pesos per board feet and equals to 58,905 pesos. Also, we have 159 pieces of 1/2 inch by 4 by 8 plywood that costs 660 per piece, which equals to 104,940 pesos. And 54 kilograms of 4-inch nails that costs 70 pesos per kilogram with a total of 3,780 pesos. For formworks for all concrete beams and slabs, we have 237 pieces of 3/4 inch by 4 by 8 plywood that costs 660 pesos per piece and a total of 156,420 pesos. Second is 1,782 pieces of 2 by 2 by 10 feet lumber, which is 5,880 board feet that costs 15 pesos per board feet and a total of 88,209 pesos. And for nails, we have 14 kilograms of 2-inch that costs 50 pesos per kilogram and a total of 700 pesos. And last is 8 gallons of form oil that costs 456 pesos per gallon and a total of 3,648 pesos. For the computation of lumber for scaffolding, so one column is to 11 lumber. So a total column is equals to 108 times mo sa 11 nga lumber, which is 1,188, ging round off na mo sa 1,190 lumbers. So formula how to get the board feet. So the formula is length times width times height divided by 12 inches. So 10 feet times 2 inches times 2 inches divided by 12 inches is equals to 3.3 board feet. So the number of lumber multiplied by board feet. So we have 1,190 lumbers times 3.3 board feet is equals to 3,927 board feet. To calculate the total cost of lumber, we multiply 3,927 board feet times mo sa 15 pesos, which is 58,900 pesos. To calculate for the plywood needed, step 1 is to get the perimeter. So the perimeter here is 0.3 plus 0.3 plus 0.3 plus ang additional joints nga 0.2. So the perimeter is equals to 1.4 meters. Step 2 is to get the area. To find the area, perimeter times height. So ang area kagina is 1.4 meters times ang height sang column, which is 3 meters. So the area is 4.2 square meters. So to get the total area, we multiply area times number of columns. So the total area is equals to 4.2 square meters times sa 108 nga columns. So ang total area is 453.6 square meters. Step 4 is to get the plywood area. So the plywood area is equals to length times width. So the value of length is 1.2 meters times ang width nga 2.4 meters. So ang plywood area is equals to 2.88 square meters. So to get the plywood needed, the total area is divided by plywood area. So 453.6 square meters i-divide sa 2.88 square meters na plywood area. So ang plywood needed is 157.5 or 158 pieces. So to get the total amount, 158 pieces times sa 660 pesos ang cost sa kada isa ka plywood. So equals sa 104,280 pesos. So to calculate for the nails, so 80 pieces of nails per 1 kilogram. Ang estimate is 1 column is to 40 nails. So the total column is 108. So 108 times 40 nails is equals to 4,320. I-divide siya sa 80 pieces per 1 kilogram is equals to 54 kilogram. So the total cost of the nails is 54 kilogram times 70 pesos per kilogram is equals to 3,780 pesos. Next is layout for all concrete beams and slabs. To calculate for the plywood needed, step 1 is to get the perimeter. So the same as sa kaginaman. So 0.3 plus 0.3 plus 0.3 plus 0.3 plus 0.2, the perimeter is 1.4 meters. Step 2 is to get the area, we multiply perimeter and length of the beam and slab. So area is equals to 1.4 meters times 3 meters. So area is equals to 4.2 square meters. Step 3 is to get the total area. So area times number of beams or slabs, the total area is equals to 4.2 meters squared times 162, which is the number of beams or slabs. So the total area is equals to 680.40 square meters. Step 4 is the plywood area. So we multiply length times width. So the plywood area is equals to 1.2 meters times 2.4 meters. So the plywood area is equals to 2.88 square meters. And step 5 is to get the plywood needed. So total area is divided by plywood area. So plywood needed is equals to 680.40 square meters. I-divide sa 2.88 square meters nga plywood area. So the plywood needed is equals to 236.25 or 237 pieces. So to get the total cost of the plywood, we multiply 237 pieces times sa 660 pesos per piece, and that causes 156,420 pesos. To calculate for the lumber, one slab or beam is to 11 lumber. So the total number of slab is equals to 162. We multiply 162 times 11 lumber. So the lumber is equals to 1,782. And the formula to get the board feet, so length times width times height divided by 12 inches. So 10 feet by 2 inches by 2 inches is divided by 12 inches. So we have 3.3 board feet. So the number of lumber is multiplied by the board feet. We have 1,782 lumbers times 3.3 board feet, which is 5,880.6 board feet. To get the total cost of the lumber, we multiply 5,880.60 board feet times sa 15 pesos nga cost ang isa ka lumber, and the total cost is 88,209 pesos. For the calculation of nails, we have 441 nails per 1 kilogram of 2 inches nails. So for one slab or beam is to 40 nails. The total number of slab or beam is equals to 162. We multiply 162 times 40 nails is equals to 6,480, and i-divide sa 441 pieces sang nails. So we have 14 kilogram. To get the total cost of nails, we multiply 14 kilogram times 50 per kilogram is equals to 700 pesos. And last is to calculate the form oil. 1 liter is equals to 120 pesos. So in 1 gallon, we have 3.8 liters. And 1 gallon is equals to 3.8 liters. I-multiply ta sa 120 pesos. So ang cost per gallon ta is 456 pesos. To calculate for the form oil needed, first is to get the total area. So total area of columns plus total area of slab or beams. The total area is equals to 453.60 square meters times 680.40 square meters. So our total area is equals to 1,134 square meters. According to our research, the estimate for 1 gallon is to 1,100 square feet. So to convert area in square meters to square feet, the formula is square feet is equals to square meters times 10.7639, which is the value of 1 square feet. Ang total area Takagina is 1,134 square meters times 10.7639. So we have 12,206.26 square feet. Since na-convertan na ang total area to square feet, so 12,206.26 square feet, i-divide na sa 1,500 square feet, so we have 8.1 or 8 gallons. So to get the total cost of gallons, 8 gallons multiplied sa 456 pesos is equals to 3,648 pesos. And that's all for my report. Thank you for listening.